Good afternoon, students.
Good
Good afternoon, students.
afternoon.
Good afternoon, sir.
Good afternoon, sir.
PCMs.
చెప్పనా బాగా తక్కువ
Okay. Very good afternoon, ma. So yesterday, what we were discussing equilibrium of the particle, right? Huh? Hello, my dear students.
Yes, sir.
Right. So toppling of an object. Let's see. Equilibrium. In that equilibrium, toppling we'll discuss. Toppling means, see, for example, this is an object. So this is on the surface of this one. On the surface. Suppose if you on this object here, if you apply force like this, then what happened? Sometimes because of this force, see here. So this is object, no? So because of this force here we are applying, what will happen? This so because of this force, this object will start rotating in the sense like this it will come with respect to this particular point. How can I tell that one? Video.
Sir, can you explain from start?
Yeah, I will explain. Right. See here. So this is on surface. This is on surface, okay? And here, so this is the object. This is the object. So this is the object. Here we are applying the force in this direction. So here, if you apply the force, what happens? So this object start rotating like this, like this. And because of this depends on the surface as well as applied force.
Because of frictional force on
So,
the surface.
So that depends on the frictional force, but so if this object start rotating like this, right? So with respect to this particular point, that is nothing but a toppling. Got it? So let's see the condition for toppling and all. So it is only at equilibrium. Object will be equilibrium. Translate and rotatory equilibrium. The object must be in rotatory equilibrium. Someone asked to explain from starting from rest case. So did you understand what I mean to toppling? Huh? Hello guys.
Yes, sir.
So that is now what I want to mean toppling. So let us consider one surface. So this is one surface. On this surface, I will consider an object. So one consider one object. This is the object. And here, so as I said, see, we consider here what are the forces are acting in each equilibrium. Normal force and another one is weight of the object. So weight of the object, right? So normal force and weight of the object acting in direction. Normal force acting in upward direction and weight of the object acting in downward direction. Now this is initially at rest. There is no any frictional forces and all. So in such cases, what happened? That equals to N equals to mg. N equals to mg. Now I am applying the force. Same object I will consider. So now I am applying the force as usual. So the weight of the object acting in no direction, and now I am applying the force in this direction here. So here I am applying the force. Okay. So here if you apply the force F, see, if we apply a external force, then another force will be acting on this object. What that force? What is that force?
Frictional force.
Frictional force,
Yes, sir.
frictional force. So frictional force is acting on this object. Frictional force. So now, actually here what will happen when you apply the force to balance this object, means to keep this object in equilibrium, the normal force is slightly shifted towards the right side, to balance this one, to balance the normal force shifted towards the right side. See, toppling is possible. When the toppling is possible, see here at this point, if your force will be more, then it started rotating like this. So when you apply, a normal force is shifting. A normal force is shifting towards right. So like this, slightly it is shifted. And so this distance, let us consider this distance. Yeah. So this is the distance here. Here slightly normal force is shifted towards right because of applied force. And further if we increase the force, then again the normal is normally shifting towards the right. Then what is the maximum distance it can shift? Maximum it can shift up to its end of that object, right? So maximum it can shift till here. Is it possible to shift other than this one? Huh? Is it possible? No. So here this is the applied force. This is the frictional force. So this is the weight of the object mg, and this is a normal force. And here how much it is distanted? So let us consider this distance. Okay. And the distance width, let us consider this is a width b, width of this object. So here see, torque is acting on due to weight of the object and normal force. Torque is acting due to weight of the object and normal force. So, and also the object is in translateral equilibrium. So to keep this in translateral equilibrium, okay, to keep this translateral equilibrium, it should be equal. that force F must be equals to the F, no? Right?
Yes, sir.
F. So translatory equilibrium. And here, so here we are applied because of these two forces itself. Again, the object started toppling. So, andre F force, small f, acting in equal and opposite directions, then a torque will be acting. A torque will be acting. So, because of this torque, the object toppling. The object started toppling. So in this case, torque we have to represent two equal and opposite forces will provide the torque, and that provides the torque. Actually, what is torque? Force into perpendicular distance, no? Force into perpendicular distance. So this force perpendicular distance will be B. So therefore, F into B, F into B, which is equal to this torque, and another torque will be provided by the weight of the object, that is mg into A. So mg into A, that is mg into A, mg into A, right? So from this, A equals to F into B by mg. F into B by mg means the how much distance it can shift the normal. The normal how much distance it can shift. That shifting of normal depends on what applied force, and then width of the object, and then weight of the object. Weight of the object. So this is not the shifting of normal shifting is not same for all the objects. It is different for different objects. And if we apply F, now force is increases, then obviously A is also increases. A is also increases, right? So and this A can be increased up to what point? Up to this only maximum. So what the width of how much object? The width of the object, half of the width of the object. That's it. That is the maximum displacement. After that, what will happen? It start toppling. It start toppling. Understood? Not understood? Okay.
Sir, the other torque should be frictional force, no, sir?
Which one?
One torque is F into P, other should be frictional force, right?
No. Here other is not frictional force, so the other is weight of the object.
Sir, can you explain the third diagram once again?
Yeah, ma'am. See, if this forces keep on increases, to keep this object in equilibrium, the normal reaction is shifting towards the applied force, and maximum how much distance it can shift up to reach this head, this end. So further, if we increases force, then what happened? The normal force is shifted to edge of the object. So here what happened? This is in a translatory equilibrium only. The object is in translatory equilibrium. So means this is not sliding. But further, if we increase the force, then this object start toppling. Means it is started rotating with respect to this point. Which point? This point. With respect to this point. So with respect to this point, this object start rotating like this, like this. That is nothing but a toppling. Okay. Then shifting of this normal and a toppling effect. When it will happen? When the normal is reaching to the end of the object and applied force further if it increases, then the toppling effect will be happen. Okay, so and this depends on what factor? The applied force, weight of the object, applied force, weight of the object, and also B, width. See, suppose we know this, generally we observe this one. Suppose if you can, and another object I will consider, mass is same. Suppose mass is same, like this if we consider. Suppose if you apply the force at this particular same point on these two objects, if you apply the force on these two same points, then which one is easily rotate? Suppose it is rotating, easily rotate with respect to this particular point, like this. Huh?
First one.
First one, no? First one means increases, then so the normal is increases, then it started toppling. So that only here we are writing, that is A equals to. So here rotating in the sense torque will be acting on it. What is the torque acting? That is F force into perpendicular distance, torque. Therefore, the applied force into perpendicular distance is B. It must be equals to the, still it is in equilibrium. This is a maximum equilibrium, right? So, and opposite torque is what? Mg into A. Mg into A. So this is mg into perpendicular distance. Then A equals to Fb by mg. This is the maximum distance the object can, the normal can shift. Further, if we increase, then it started rotating. So if suppose further it can't move, the normal is can't move. If we increase the F, then it started toppling. ಇದೇ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿಸ್ಟೆನ್ಸ್. ಈ ಡಿಸ್ಟೆನ್ಸ್ಗೆ ನಾವು ಮತ್ತೆ ನೀನು ಜಾಸ್ತಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇವಾಗ ಏನಾಗ್ತದೆ, ಎ ವಿಲ್ ಬಿ ಇನ್ಕ್ರೀಸಸ್, ಟ್ರೈ ಟು ಇನ್ಕ್ರೀಸಸ್, ಬಟ್ ಹಿಯರ್ ದೇರ್ ಇಸ್ ನೋ ಪಾಸಿಬಿಲಿಟಿ increase. That time what will happen? These objects started toppling. Got it?
Sir,
Yes, sir.
toppling means rotating, no sir? Toppling means rotating. We can say like that.
Rotating with respect to this particular point, ma.
Okay, sir.
Not sliding or rotating with respect with respect to this point. Okay, one edge of the corner of the point.
Okay.
ಅರ್ಥ ಆಯ್ತಾ? Right. Shall I go for next one?
Yes, sir.
Shall I go for next one, ma?
Yes, sir.
Yes, sir.
Right, next one. So movement of inertia.
Sir, that F into B was there, no? That was coming outside the screen, and mg into A was going inside. So you equated both because opposite torque was it. So both were like in opposite direction. F into B was outside the screen, and mg into A was inside the screen. So you equated both, right?
I didn't get right. What you
Can you once go to previous page, sir?
No.
Sir, if it is in rotational
Okay,
equilibrium, then the torque which is coming outside the screen should be equal to torque which is going inside the screen. F into P is coming outside, and mg into A is going inside. So you equated both. That was doubt, sir. That's it.
Finished? Who is that? Anisha?
Done, sir.
Okay. Movement of inertia. Very important one, ma. Movement of inertia. Best example ಹೇಳ್ತೀನಿ ನೋಡ್ರಿ. So we have one rod. Suppose we have one rod. Mm. Okay, so this is one cylindrical rod. Okay, see here. So suppose now I will rotate this cylindrical rod like this. This is a rotation axis. This is a rotation axis. This is the first rotation. Then this is a second rotation axis. This is a second rotation axis. Andre first time ಹಿಂಗೆ rotate ಮಾಡ್ತೀನಿ, second time ಈ ತರ rotate ಮಾಡ್ತೀನಿ. So third one, the rotation axis will be this one. This is a rotation. So now the object is rotating like this. Third rotation. Out of all these three, axis of rotation is which axis is easy to rotate? Which axis is easy to rotate?
First one, sir.
See. Okay. This is one object. One is I am rotating like this. Like this. Other one is rotating like this with respect to this axis. So either. Okay. Third one is rotating like this. Out of these three, which one is easy to rotate?
Third one.
Third one.
Third one.
Third one is easy to rotate now?
Yes,
Okay.
sir.
So third axis. See here, the mass is remains same. The mass of this entire object remains same. Mass is same. But the rotation axis I have changed. The rotation axis. So rotation axis, if we change it, then 1 minute. Okay. Rotation axis changed and the rotation is easy in the third case. And which one is difficult among all these three?
Second.
See, once again.
Second one, sir.
Second one, huh?
Yes, sir.
Right. Second one is difficult to rotate it. Fine. Right. Next one, see the same condition. I will take the another one example. So in this case, the axis of rotation will be exactly at midpoint. So axis of rotation will be same. Okay. So this is same. This is the first case. So first I will rotate like this. Okay. Second case, what I will do? So I will add some extra mass. For example, dumbbell. Dumbbell, you know, dumbbell. Dumbbell ಗೊತ್ತಲ್ಲ?
Yes, sir.
So dumbbell ತಗೊಳ್ರಿ. Suppose ಅಂದ್ರೆ dumbbell ಈ ತರ ಐತೆ ಅಂತ ಕೇಳ್ರಿ. Diagram ಐತಲ್ಲ ಆ ತರ ಐತೆ ಅಂತ ಕೇಳ್ರಿ. Let us imagine. So this is the dumbbell. Okay, this is the dumbbell. This is the dumbbell. Now the axis of rotation is this one. So first I am rotating like this. The second time what I will do, I will bring these two masses. So these two masses here. Here I will bring these two masses. This is the second case. Again I am start rotating these two objects. In the third case, so I will bring these two masses here only and I can hold those two masses and start rotating. Start rotating. This is third case. ಅರ್ಥ ಆಗ್ಲಿಲ್ವಾ?
Yes, sir. Right.
So second case you say was
So this mass I brought to here and this mass I brought to here. Okay, and start rotating. Again, third case. So this mass I brought to here and this mass I brought to here at the axis of rotation, and I'm holding those two masses and started rotating. Third case. So in all these three cases, which one is easy?
Third case, sir.
Third case is easy, na?
Yes, sir.
So ನಿಮ್ಗೆ ಏನು ಡೌಟ್ಸ್ ಇದ್ರೆ ಬೇಕಾದ್ರೆ ನೀವು ಚೆಕ್ ಮಾಡ್ಕೊಳ್ರಿ, ಓಕೆನಾ? ಸೊ ಜಸ್ಟ್ ಯು ಕ್ಯಾನ್ yourself take one pipe or something else and take two masses and all. You can just rotate what I like to that. Then which one you feel difficulty, you inform me in the tomorrow's class. So actually here, see, in the first case and in the second case, if we observe, in the first diagram and the second diagram, in the first diagram, the third case is easy to rotate. Third case is easy to rotate. So easy to rotate means the axis of rotation, distance from the axis of rotation to the mass is very less. R value is very less. And if we consider the second diagram, in the second diagram, what happened? The distribution of masses. See, in the first case, the mass is very here. The masses are at the end of the rod, but in the third case, it come to midpoint. Means if the distribution of masses is changes, then rotation is also changes. Yes. So rotation means we can say the rotation depends on two factors. So linear motion, if we consider the linear motion, just if you have, this depends only on force F and frictional force and all, but that F force equals to me. But in case of a rotation, if we consider, so this rotation is depends on two factors. One is mass, distribution of mass. The second one is
Axis of rotation.
where we are considering the axis of rotation. Nothing but a distance from the axis of rotation to the mass. That also depends on these two factors depends. So now means these two are acting as a resistance for the rotation. Yes, yes or no? M
Yes, sir.
as well as R. But in case of a linear motion, only mass can act as a resistance, sir. Inertia. Measure of inertia is what? Mass. Measure of inertia is mass. Now, but if we consider here, the measure of inertia is mass of the object as well as distance r. So that is nothing but a movement of inertia in rotatory motion. Simply we can say the movement of inertia is nothing but a inertia in rotatory motion. What is that one? Inertia in rotatory motion is nothing but a movement of inertia. ಅರ್ಥ ಆಯ್ತಾ? ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಂದ್ರೆ ಏನು?
Yes, sir.
Right. So this can be written as moment of inertia. So this is inertia in rotatory motion. So clear this one. So moment of inertia. So that is inertia in rotatory motion. So in rotatory motion, and this can be written as moment of inertia represented with I. So I equals to mr square. I equals to mr square, where m is the distribution of mass. So or just you can write mass, distribution of mass, and r is called
Radius of gyration.
r is called radius of gyration. Radius of gyration. Okay, radius of gyration. is the moment of inertia. And what about the SI units? So SI units, if we consider SI units, what is the SI units of mass? That is
M
kg.
power 1, yeah,
Is
kg, meter square.
is in
That's it.
and dimensions.
M power 1, L power 2, T
M
power 0.
L square T power 0. M L square T power 0. Okay. So the moment of inertia. If you apply a moment of inertia for a particle, okay. So moment of inertia for system of particles. Inertia for system of particles. Particles. See. So consider an object. This is an object, and suppose this object is rotating with respect to this axis. So this is axis, and here consider. So this is object M1, and its distance is how much? Let us consider R1, and this is object M2, and distance is R2, and object M3, distance is R3. So all these are rotating with respect to, these are rotating. So with respect to this is rotating, and this is rotating, and this also rotating like this. Then the moment of inertia of all these we can written as moment of inertia of first object plus moment of inertia of second object plus moment of inertia of third object and so on. So what can write, that is m1 r1 square plus m2 r2 square plus m3 r3 square plus and so on and so on. So at last we can write m equals to summation of, so mi ri square, I equals to 1 to n. So this is nothing but a moment of inertia of system of particles. ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
See, okay, shall I go for next page?
1 minute.
Yes, sir.
Sir, 1 minute, sir. 1 minute, sir.
Uh,
Okay, sir.
okay. Next one. Radius of gyration. So radius of gyration. Radius of gyration. So actual moment of inertia we have written. So moment of inertia is nothing but a inertia. So we have inertia, we have written I equals to what? M R square. Or we can also write ORR. This can be written as I equals to M K square. K. We can also write K. Here R ORR K is what? Radius of gyration. And what is the radius of gyration means?
Distance from
So,
axis of rotation to center of mass.
yes. Suppose this is an object. Suppose this is object is rotating with respect to like this. This is a rotation. And so its center of mass is this one. Is there no? It may be R or K. This distance, the distance from the axis of rotation to the center of the mass of the body is nothing but a radius of gyration. So the distance from center of mass to the axis of rotation. Axis of, so this is the radius of gyration. And okay, for symmetrical bodies, if we consider for symmetrical bodies, it may be circular or it may be ring and all. So the radius of a circular ring and disc and sphere, if we consider, then the radius of gyration is nothing but a radius of that particular object.
Sir, but one doubt.
Yes.
If we consider uniform rod, okay, uniform rod, and perpendicular to that rod, exactly at the center of that rod, axis of rotation is there. Then distance from axis of rotation to center of mass is 0, right? How it is mr square by 12?
I will tell that. We will derive now. So finished? Huh? What is the radius of gyration and all?
Yes, sir.
So actually here few radius moment of inertia of bodies are there. So these we have to remember this moment of inertia of body, few things, so that these are repeating in each and everything, each and every concept. So even in other chapters also it will come radius of gyration and all. Radius of gyration and moment of inertia. So those are ringu, sphere, disco, cylinder, all this. Remember movement of inertia. How we are remembering the center of mass? Center of mass is in the same way movement of inertia also. But the thing is, the movement of inertia is changes if rotation is changes. Okay, moment of inertia is changes if axis of rotation is changes. Right. Next one, two laws are there, that is parallel axis theorem and perpendicular axis theorem. So parallel axis theorem and perpendicular axis theorem. See, so statement, these are very big statements. So you just go through your book once, statements ge, and explain ಮಾಡ್ತೀನಿ ಇಲ್ಲಿ. So these parallel axis theorem and perpendicular axis theorem are used to find the moment of inertia of objects, any objects. It may be a symmetrical bodies or non-symmetrical bodies. So ಈ ಎರಡು theorems ನ use ಮಾಡ್ತೀವಿ, right? So parallel axis theorem and perpendicular axis theorem. Here perpendicular axis theorem is applicable only for planar bodies. Plane, only for plane. But parallel axis theorem is applicable for everything. So planar bodies in the sense, you suppose a sheet of paper, if you consider
Dimensional bodies.
two-dimensional body, yeah, two-dimensional. It doesn't have any volume, so it is applicable. Perpendicular axis. Parallel is you can apply for anything. So first, if you consider parallel axis theorem, see, I will consider one object. So this is one object. Now the center of mass of this object is this one. So this is the center of mass of this object. The mass of the object is m. Now if we consider axis of rotation along the center of the mass, then suppose this object is rotating with respect to this one. Let us consider the moment of inertia of object with respect to center of the mass is, let us consider I naught. So here I naught is what? Moment of inertia body along its center of mass. The axis of rotation is along center of mass. Now, if you want to calculate the moment of inertia any other point, say for example this point, at this point you have to calculate. So now this point, so draw one axis of rotation. Now you need to calculate the moment of inertia at this particular point. At this particular point. So this can be written as the moment of inertia of a at any point. The moment of inertia of a body at any point is equals to sum of the moment of inertia of a body along the center of mass and product of the total mass of the object and perpendicular distance between the two parallel lines. Two parallel lines. That is I equals to I naught plus mr square. So what I said, moment of inertia of a body at any point, axis of rotation should be parallel to the axis of rotation along the center of mass. So first center of mass the moment of inertia of center of mass is I naught, and this you have to calculate that I naught plus mr square. So this is a parallel axis theorem. Parallel axis theorem. Statement artha aita?
Yes, sir.
Perpendicular axis theorem. So consider a planar object. So this is one planar object. Let us consider. And here, so this is along x-axis, this is y-axis, and this is z-axis. So x, y, z. So here, the moment of inertia of a body along z-axis, the moment of inertia of a body of a planar lamina, perpendicular, so its x and y axis along its z axis equals to sum of the moment of inertia of a objects along two axes, remaining two axes, that is x axis and y axis, along x axis and y axis. So that is nothing but Iz equals to Ix plus Iy. Andre idon planar lamina adre idu x axis, idu y axis, z axis will be what? Z axis. Then what is the moment of inertia of this object with respect to z axis? Equals to moment of inertia along x axis plus moment of inertia along y axis. So this is nothing but a perpendicular axis theorem, and this perpendicular axis theorem is applicable for planar objects, but parallel axis theorem we can apply for anything. Arthamainda? Statement.
Yes, sir.
Okay. So do one thing, those two statements now where do know. Nim notes all barkandri, a statements tumba important. After that, these two equations you write. So definitions you will not understand easily. Tomorrow we will solve the problems. You can understand the theorems, all these theorems. Okay na? Problems solve madda nimge chinnaga artha agtate. So ಅದಕ್ಕಿಂತ ಮುಂಚೆ ನಿಮ್ಮ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ಪೇಜ್ ನಂಬರ್ 103 ಅಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಅದರಲ್ಲಿ ಜಸ್ಟ್ ಡಿಫ್ರೆಂಟ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆ ಡಿಫ್ರೆಂಟ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಅಲ್ಲಿ ಒಂದು 3 ಯಾವ್ಯಾವ ಅಂದ್ರೆ, ಓನ್ಲಿ ಫಸ್ಟ್ ಒನ್ ರಿಂಗು, ಸರ್ಕ್ಯುಲರ್ ರಿಂಗು, ನೆಕ್ಸ್ಟ್ ಡಿಸ್ಕ್, ಸಿಲಿಂಡರ್, ಸ್ಪಿಯರ್. Center of mass. Just you ಮಾತ್ರ ನೋಡ್ಕೊಂಡು ಬರ್ರಿ, ಏನು ಕಲ್ತ್ಕೊಂಡು ಬರ್ಬೇಡಿ. Just center of mass. So what is the moment of inertia of a ring passing through its center of mass? ಅವನ್ನ just ನೋಡ್ಕೊಂಡು ಬರ್ರಿ. Okay? Okay ಮಾಡ್ತೀರಾ?
Yes, sir.
Yes, sir.
Okay, fine. So we'll continue in the tomorrow's class. Bye bye. Take care. Do you have
Okay,
any
sir.
other
Bye,
questions?
sir.
Bye.
After ಸ್ವಲ್ಪ ದೊಡ್ಡದು and important ಸ್ವಲ್ಪ complicated ಅಪ್ಪ, so concentration ಮಾಡ್ರಿ.
Yes, sir.
Okay, sir.
Thank you, sir. Bye, sir.